In this video, we're going to talk about relative velocity. So when you hear the word relative velocity, what do you think of? What I think of, you're talking about the velocity of an object relative to something else. And whenever you want to calculate the relative velocity, it's basically the difference between two velocities. So let's say if we have the variable VBA, you need to understand what this means. What this means is you're talking about the velocity of object B with respect to object A. So B is the object that you're considering, that's the object in focus. A is the reference frame or the frame of reference. So how can we calculate VBA? How can we find it? So this is the velocity of B with respect to A, and it's basically the difference between VB and VA. Now, if you see me write VB throughout the remainder of this video, what I mean is VB is really the velocity of B with respect to the Earth. So let's say if a train is moving at 30 miles per hour with respect to the Earth, if you're standing on the ground, not moving, to you the train is going to appear to be moving at 30 miles per hour. So if I just write one letter, one subscript, then assume that it's always with respect to something that's stationary. In this case, a good example will be the Earth. So VA is the velocity of object A with respect to the Earth. Now, let's say if we want to define VCA, that's the velocity of C with respect to A. So you can calculate it by subtracting VC and VA. Now, if you want to find V of A of C, that's the velocity of object A with respect to C, where C is the frame of reference. Then this is going to be VA minus VC. So if you want to find the velocity of object C with respect to B, that's VC minus VB. And the velocity of object B with respect to C is VB minus VC. So basically, relative velocity is just the difference between the velocity of the object minus the velocity of the frame of reference, which I'm just going to put FR. So that's the formula to calculate relative velocity. And we're going to go over some examples that's going to illustrate it. So let's say this is a train or a train cart, and there's a person inside it. Let's call this person person A. And the train is moving at 50 miles per hour with respect to the Earth. And there's another train, train B, that's moving at 60 miles per hour. Now let's say there's a person on this train as well. Now, if they're both moving in the same direction, calculate the relative velocity of B with respect to A, and also find the relative velocity of A with respect to B. So train B is moving 10 miles faster than train A. So the velocity of B with respect to A is simply 10 miles per hour. The way you would calculate it is it's going to be VB minus VA. VB is 50. VA is 50. I take that back. And VB is 60. So it's going to be 60 minus 50, which is 10 miles per hour. So that's the velocity of B with respect to A. Train B is moving 10 miles per hour faster than A. And the velocity of A with respect to B, it's VA minus VB. That's 50 minus 60, so that's negative 10. So A is moving 10 miles per hour slower than B. So that's how you can find the velocity of A with respect to B. Now let's think about what this means. So let's say this is A and this is B. So A is moving at 50 miles per hour east, and B is moving at 60. Now we said that V, the velocity of B with respect to A, is positive 10. So that means that B is going 10 miles per hour faster than A if they're moving in the same direction. So in 1 hour, A is going to travel a distance of 50 miles. And our reference frame is A. So B is going to travel a distance of 60 miles. So in 1 hour, B is going to be 10 miles ahead of A. So if you're a person on train B and you're looking at someone on train A, to you, it's going to appear as if you're moving 10 miles faster than A. Imagine if you're in a car and you're on the highway going at 60 miles per hour, and there's another car beside you traveling at 50 miles per hour. Now, eventually, you're going to move past the other driver because you're going faster. But you're not going to move past him quickly. It's going to happen over time. But slowly, you're going to move past him. And in 1 hour, you're going to be 10 miles ahead of person A. So that is your relative velocity with respect to A. It's 10 miles per hour. So every hour, you're going to gain 10 miles from person A. Now, let's analyze it if B is the reference frame. The velocity of A with respect to B, where B is the reference frame, is negative 10. So in 1 hour, A is going to travel a distance of 50 miles. And in 1 hour, B is going to travel a distance of 60 miles. So keep in mind, B is the reference frame. So with respect to person B, someone in train B is going to look at someone in train A, and it appears as if train A is moving towards the left with respect to B. Because before, they were at the same location, but now, if you're someone on train B and you're looking at the person on train A, it appears as if, with respect to you, that the person in train A is moving towards the left. And in 1 hour, he's going to travel 10 miles towards the left. So with respect to you, his displacement is negative 10. And thus, that's why we can see that it's negative. So with respect to someone on train B, a person on train A will appear to be moving towards the left. And that's why we have a negative relative velocity. In the other example, where A was the reference frame, a person on train A, looking at the person on train B, sees that person moving 10 miles per hour away from them, towards the right. And so that's why the relative velocity of B with respect to A is positive, because the person on B is moving towards the right, away from person A. And so hopefully this helps you to understand the sign of relative velocity and what it means. Now let's work on another example. So let's say if there's a person on train A and they're moving east at 50 miles per hour. So that's a VA with respect to the Earth. And then there's another train with a person on it. Let's call that train B. And he's moving 40 miles per hour west. So the velocity of B with respect to the Earth is negative 40 because he's going towards the left, or the negative x direction. So here's a question for you. What is the relative velocity of A with respect to B? And what is the velocity of B with respect to A? Now, before you actually calculate it, predict which one is going to be positive and which one is going to be negative. Now, A is moving towards the right with respect to B. So as time progresses, A is going to keep moving to the right. So the velocity of A with respect to B should be a positive answer. Now, B is moving towards the left. And over time, it's going to eventually be left of person A. So VB with respect to A is going to be negative. Now, to actually calculate V of A with respect to B, that's going to be VA minus VB. So it's 50 minus negative 40, which is 50 plus 40, so that's 90. So in 1 hour, A is going to move 90 miles closer to B. So let's say if they were initially 200 miles apart. In 1 hour, A is going to move 50 miles. And also B is going to move 40 miles towards the left. So now, if A is located at this point and B is right here, they are now 110 miles away from each other. So therefore, the distance went from 200 to 110. The distance decreased by 90. So therefore, the relative velocity is 90 miles per hour. Every hour, the distance between them will decrease by 90. Now, the velocity of B with respect to A, that's going to be VB minus VA, where VB is negative 40 minus VA, which is positive 50, so that's negative 90. So if we analyze the velocity of A with respect to B, it's positive 90. A person on train A every hour is going to move 90 miles closer towards B towards the right, so in a positive x direction. So that's why it's positive 90 miles per hour. Now looking at the velocity of B with respect to A, a person on train B is moving towards train A, but to the left. So because they're moving towards the left, every hour they're going to move 90 miles closer to the left towards train A. So that's why the velocity of B with respect to A is negative 90. Now let me give you another practice problem. So let's say if we have another person on a train, or let's say the person's on a car or something, and this person, well, let's say the car is moving at 40 miles per hour with respect to the earth, and the person driving the car throws a ball east at 15 miles per hour with respect to the car. And there's another car approaching the first car, and let's say this car is moving 60 miles per hour towards the west. So what I want you to do is I want you to find the velocity of the ball with respect to this person. So let's say this is this is car A, this is the ball B, and this is car C. So we could distinguish everything. So what is the velocity, the relative velocity of the ball with respect to car C? Feel free to pause the video to get this answer. So let's define what we have. The 40 miles per hour represents what? What variable does it represent? That's the velocity of car A with respect to the earth. The 60 miles per hour is the speed of car C. But if you want the velocity of car C with respect to the earth, it's negative 60 because it's moving towards the left. Now the 15 miles per hour, that's the velocity of ball B, not with respect to the earth, but with respect to car A. So our goal is to find the velocity of the ball with respect to car C. In order to find the velocity of the ball with respect to the car, we need to use this equation, VB minus VC. Now we have VC, but we don't have VB, so we need to find another way of getting VB. So we need to use an equation that relates VBA with VB. Now VBA, the velocity of the ball with respect to car A, is the velocity of the ball with respect to the earth minus the velocity of car A with respect to the earth. So VBA, we have positive 15. It's going towards the right. VB, we don't know, but VA is 40. So in order to find VB, we got to add 40 to both sides. So therefore, VB is 15 plus 40, so it's 55 miles per hour. And it makes sense, because if the car is already moving at 40 miles per hour, and you throw the ball 15 miles per hour towards the right, then this ball will appear to be moving at 55 miles per hour with respect to the earth, or with respect to a stationary observer that's standing on the road. So that answer makes sense. So now that we have VB, let's use it to find VB of C. So the velocity of the ball with respect to car C is going to be equal to VB minus VC, which is negative 60. So that becomes 55 plus 60, which is 115. So now let's make sense of everything. So let's say if the two cars are 300 miles apart, and car A is moving at 40 miles per hour, and the ball is moving at 15 with respect to car A. And then car C is moving at 60 miles per hour. So in 1 hour, car A is going to move a distance of 40 miles. And then on top of that, in 1 hour, the ball is going to move an extra 15 miles beyond car A. And car C in 1 hour is going to move a distance of 60 miles. So therefore, the distance between the two cars is no longer 300, but it's 300 minus 115, which is 185. So in 1 hour, the distance between car A, the distance between the ball and car C is now, it went down from 300 to 185. So the distance changed by 115. So therefore, we can say that the velocity of ball B with respect to car C is 115. If you compare the ball and car C, in 1 hour, they're 115 miles closer. So the velocity is going to be 115 miles per hour. So hopefully that illustration helps you to understand the concept of relative velocity.